In this video, we're going to consider this integral and how we can transform it into this standard form of an elliptic function. And you saw in the previous video when we introduced the elliptic functions, indeed this is, I think it's called the first or second standard form, I forget which one, but anyway we had derived this from the Legendre form of the elliptic functions. To find that video, if you go to the website at digital-university.org, then click where it says Free Calculus Videos, and then scroll down where it says Integral Functions. You'll see we have videos on the gamma function, the beta function, and beneath that, the elliptic function. So here, for this video, we want to get this integral into this form. And we see that maybe if we call this, take the square root of this, call it u, so you let u equal 2x, so then we'll have 1 minus u squared down here. That'd be the same general form as this. Then if we do that, 1/2 of du will equal dx. Now up here we have x squared, but x is just u over 2. So we'll have a substitution for that. Now the limits here, x goes from 0 to the square root of 3 over 4. This is our substitution. So u, if x is 0, u is 0. And if x is the square root of 3 over 4, then u will be the square root of 3 over 2. So let's put these substitutions into the integral. We're going from 0 to the square root of 3 over 2. Let's do this last. We'll take care of this first. We have 1 minus u squared, the way we set it up. Then in the numerator it's 2 minus u squared over 4 for x squared. And then dx is 1/2 of du. So a simple substitution, and we're getting closer now to having this in a standard form. 1 minus u squared, we're okay there, but here this has to be a 1. So we'll factor out the 2. So we're going to have in the numerator, it's going to be 2 times 1 minus u squared over 8. And then we'll take the 2 to the outside of the square root. Now we'll have a square root of 2 then. So we'll have a square root of 2. And this is 1 minus u squared over 8. Now it looks like we should be at least close to having it in standard form. Remember that the limits go from 0, and the highest value we can have is 1. This has to be some fraction, and indeed it is. And now here we have k squared times x squared. So k squared equals 1 over 8, or k equals the square root of 1 over 8, or that would be 1 over the square root of 8. And then we could probably, let's see, the square root of 8, that's the same thing as of 1 over the square root of 4 times the square root of 2. So we have 2 times the square root of 2. If we want to, we can multiply top and bottom by this. So we have k equals 1 over the square root of 8, or we could say k equals the square root of 2. Square root of 2 times the square root of 2, that's 2 times 2 is 4. Now, remember in the introductory video when we were discussing elliptic functions, we were saying that this is the trig form right here, and then for the algebraic form, we started with these and then we derived these, that for the elliptic functions there is no standard functions to represent them. They do have a numerical value depending upon the value of u, our upper limit, and what k is. So all we're going to say then is for this integral right here, then we had the square root of 3 over 4, but that got transformed to the square root of 3 over 2 when it's in standard form. So what we have then is it has a value, e, for the elliptic integral. It's expressed as ku once it's in standard form, like this, where k now equals the square root of 2 over 4, and u is the square root of 3 over 2. And then if we want, we can look this up in a table of values to see what numerical value it has. We're going to stop here. The main point of this problem was just taking an integral that has a rational function and seeing if there's a way that we could transform it so that it conforms with the standard definition then, or one of the standard forms of an elliptic function. And here it was pretty straightforward, realizing that for our squared term it has to have a coefficient of 1. We made this substitution then. Then once we did that, everything else pretty much fell into place, so that this was transformed into this, u squared divided by 8. And here we have k squared, so k is 1 over the square root of 8, or we can get it into this form. And then the upper limit, once it's in standard form, is this. So the numerical value of this integral, oh, we forgot to write this in. So let's have it right here. This integral, we'll call this integral I, equals the square root of 2 over 2. Then we have times whatever numerical value this has. So the integral that we started with, this comes down to this expression, and again we can look up in a table of values what numerical value this has. That's straightforward enough to do, so that we won't do it in the video here. What we wanted to do though is just take a straightforward example and kind of give the numerical approach of what it takes then to have an integral, a rational one like this, and try to get it into a standard elliptic integral so that we can get this kind of an expression for it in the end. Okay, that's it for this video. Come back and join us for some other videos, and we'll try and work some more problems here and have some other examples that won't be quite so straightforward.